Guys, today we are going to do some solving polynomial equation by factoring. So, a couple of things to remind us. One, we always want to make sure that when we're solving, we're making the equation equals 0. That's very, very important. Two, when we're factoring, remember that we are going to factor out our greatest common factor first. Greatest common factor first. And from factoring polynomials from a couple of lessons before, we know that when there are 3 terms, we're going to try to factor using the X box. When there are 4 terms, we're going to try to factor using grouping. And then when there are 2 terms, we're going to try to factor using special product or special patterns using a formula chart. All right, so let's take a look. The first thing I want to make you aware of, this example 1, is that there's actually a typo in there. The correct equation should be 2x cubed minus 12x squared. I left out the square on that original equation, plus 18x equals 0. That should be the original equation. Okay, so let's take a look. First thing first, I need to make it equals 0. Absolutely, it is equals to 0. Now, what is the greatest common factor? I got a 2x cubed, 12x squared, and 18x. All of those numbers can be divisible by 2. So my greatest common factor for this one is 2. Not only is it 2, if you look at the variable, I have 3 x's, 2 x's, and 1x. All 3 of these terms has 1x in common. So your greatest common factor is actually 2x. Well, let's divide it out. You're going to get 2x, and that's going to leave you with x squared minus 6x plus 9. Still equals 0. Now, at this point, you're going to want to factor out x squared plus minus 6x plus 9. 2 things you notice. 1, it has 3 terms. It has x squared, it has a minus 6x, it has a plus 9. So you could definitely go with an x box and see if that would help you factor it out. Now, some of you might have noticed that this is a perfect square. Remember going back all the way back to last unit when we did completing the square. If I take the middle term divided by 2, so that would give me 3, and then square the answers, so 3 squared is 9. That would give me my last term. This is a perfect square. So this can actually factor it out to be x minus 3 times x minus 3. Now, if you're like some of us, or if you were like me when I was back in Algebra 2, student myself, you might not have seen that right away. You can definitely still do the x box, and that will still get you to x minus 3 times x minus 3. The x box would be 9 on top, negative 6 on the bottom. To multiply to get 9, add to get negative 6, I would need a negative 3 and negative 3. That means that I have x squared on the first box, 9 on the last box, negative 3x, negative 3x on the diagonal box. Greatest common factor is x. X times x is x squared. X times negative 3 is negative 3x. X times negative 3 is negative 3x. Notice how that still got me a factor of x minus 3 times x minus 3. Don't forget to pull the 2x, your greatest common factor, down. Still equals 0. Now, if I know that all 3 of these numbers multiply to have to be a 0, that means that 2x, one of the factor, would have to be a 0. So 2x has to be a 0, or the x minus 3 has to be a 0. So in this case, I would set it all to equals to 0. 2x equals to 0. X minus 3 is equal to 0. Solving it, x equals to, divided by 2 on both sides. So that would be x equals to 0. Add 3 on both sides. This would be x equals to 3. I have solved my polynomial equation. Now, you could definitely check it on your calculator. You can graph this equation, 2x cubed minus 12x squared plus 18x, as one graph, and then graph y equals to 0 as the other graph, and find the intersection. Another way of thinking it, you're finding zeros of the graph. So I'm going to go to my graph. I'm going to go to my calculator, go to new document. No, I don't want to save anything. Add a graph. Okay, let's type in that equation. 2x to the third power minus 12x squared plus 18x. And I'm going to graph it. And there, if I were to graph y equals to 0, I would have a horizontal line right through the axis, right on top of the x-axis. And that means the intersection of the two lines would be this point right here and this point right here, which is also called the zeros. So I could go to Menu, Analyze Graph. Nope, not Trace. Analyze Graph. And then go to my zeros. And then just highlight each one of these zeros. Just highlight that 0. And I can see that that is x equals to 0. Do it again. Analyze Graph. Go to 0. And then again, highlight the other zeros. I can definitely move the points. So hover until you have a grabby hand. Click and hold the center until it grabs and move it aside. So the other zeros is at x equals to 3, which is exactly what we found right here. X equals to 0 and x equals to 3. So that's example number 1. So there are a couple of things that you would need to know about these factors, about sketching the graph if you did not have a calculator to begin with. So the first thing you need to know, when a factor x minus k of f of x is raised to an odd power, you need to know that the graph goes through that 0. What does that mean? This is what it means. If I have x minus 3 raised to the third power, when I'm graphing it, I know that my graph is going to go through this 0 at x equals to 3. So here's my x equals to 3. Here's my 0 right there. Since this is a positive odd, I know that my graph goes this way, goes up on the right, goes down on the left. I know that this is just going to hit that x equals to 3 and then keep on going. The line's going to go straight through that 0 that was created by that factor. Now, when the factor x minus k is raised to an even power, then I know that the graph bounces on that 0. What does that mean? For example, if I have x minus 3, but if this time it's raised to the second power, that is an even power, what's going to happen is on that x equals to 3, my graph is going to come down to that point, touches that point, doesn't go through it, but actually bounces back up. So that's what it means when I say bounces off the point. So when the exponent is even, the graph bounces off of that 0. When the exponent is odd, the graph goes through that 0. This is a very useful information for you to have in order for you to sketch a graph, which is exactly what we're going to do next. If you flip the page, on page 20, example 2 asks you to do two things. One, it asks you to find the zeros. Finding the zeros is the same thing as solve. Of f of x equals to negative 2x to the 4th plus 16x squared minus 32. Well, let's solve it. In order to solve it, I know I have to make it equal to 0. So I got negative 2x to the 4th plus 16x squared minus 32 equals to 0. Okay, first thing first, greatest common factor. I notice that 2 goes into all three of these numbers. And there's a negative as my first term. So I'm going to factor out a greatest common factor of negative 2 because I always want my first term to be a positive number. So that's going to give me negative 2 times x to the 4th plus 8x squared minus 16 equals to 0. Again, if you see the perfect square pattern in here, great. You can keep moving. If not, you can always do an X box. Here's the X, negative 16. Multiply to get negative 16, add to get 8. So that's going to be negative 4 times negative 4. I actually made a mistake. When I divide out a negative 2, this instead of positive 8 should be a negative 8. This should be a positive 16. So that's going to give me positive 16, add up to be negative 8. So that's negative 4 and negative 4. And when I put it in the box, you have x to the 4th up here, 16 down here, negative 4x squared, negative 4x squared. So that's going to give you x squared as the greatest common factor because there are 4 x's in this box. There are 2 x's in this box, so they have 2 x's in common. This is x squared, this is going to be x squared. This is going to be minus 4. This is going to be minus 4. So this is what I have. Negative 2 times x squared minus 4 times x squared minus 4. Now this is tricky because x squared minus 4 is a special pattern. This is a perfect square minus a perfect square. That is an a square minus b square. I can rewrite that as negative 2 times x minus 2 times x plus 2. That's for the first x squared minus 4. For the second x squared minus 4, I can factor it out the same way. X minus 2, x plus 2. So if I were to rewrite this, I would have negative 2 times x minus 2 squared times x plus 2 squared. And all of these are still equal to 0. So when I'm solving this, I know that x minus 2 has to be 0 or x plus 2 has to be 0. So I know that, let me go up to this point, x minus 2 has to be equal to 0, therefore x is equal to 2. X plus 2 has to equal to 0, therefore x is equal to negative 2. So those are my two zeros. All right, so let's sketch that graph. When you're sketching a graph, these are the pieces of information you need. You need your zeros, which we found, x equals to 2 and x equals to negative 2. You need your y-intercept. Your y-intercept should be your c. your last term, your constant. And then you need your end behavior. And in this case, if you look at the equation, it is a negative leading coefficient, even degree. That means my end behavior is going to go down on the left, down on the right. Let's see. I got a 0 at x equals to 2 and x equals negative 2. Let me write that down. Here is 2. There's a 0 right there. Here's negative 2. There's a 0 right there. I know my y-intercept is c, which is my constant. So if I were to go back to my equation, here's my constant, negative 32. Okay, so let's say that this is negative 32. So I have a y-intercept right there. And now my end behavior, I know that it goes down on the left and it goes down on the right. So what that means is that when I go up to this zeros, this is where that little tidbit that I told you earlier is going to come in handy. When I go up to when 0 is x equals to negative 2, if I look at my factor over here, when x equals to negative 2, I'm looking at x plus 2. My factor is raised to the second power. Remember that when it's even, it bounces. So that means on my graph, I'm going to go up to negative 2, but I'm not going to go across. I'm going to bounce right back down. And somehow, I need to reach negative 32 on the y-intercept and get back up to my x equals to 2. So, easiest choice, most logical choice would be to curve down and curve right up. And when I get to when x equals to 2, let's go back to look at my factor. That's x minus 2. Looking at my factor, x minus 2 is raised to the second power. That is an even exponent. When it's raised to an even power, it bounces. So again, this one doesn't go through. It actually bounces, turn back around, and join my end behavior in going down on both ends. And there I have just sketched the graph of negative 2x to the 4th plus 16x squared minus 32.